Here's the roadmap. We start in the bone marrow, where cells cut and reassemble DNA to build receptors for threats the body has never seen. Then trace how that huge diversity gets generated and used when a new virus appears. From there, we follow the classic innate and adaptive branches, with dendritic cells carrying evidence to lymph nodes, T cells activating, and B cells refining antibodies through rapid mutation and selection. We also look at why most immune cells live in the intestines, how gut microbes and dietary fiber shape immune education, and why the balance between tolerance and attack matters so much. Then the video turns to trained immunity, showing how innate cells can remember past encounters through epigenetic changes and respond differently the next time. It ends with the bigger takeaway. Immunity is an ongoing learning process shaped by microbes, sleep, antibiotics, and everything the body has already experienced. Somewhere in the bone marrow right now, a cell is cutting its own DNA into pieces and stitching it back together at random. This is not a mistake or a disease. It is a feature. That molecular gamble, repeated billions of times across a lifetime, is how the body manufactures an army capable of recognizing threats it has never seen, and in many cases, threats that do not yet exist anywhere in nature. The immune system is the only human tissue that intentionally rewrites its own genetic code in order to do its job. The scale of this internal improvisation is difficult to comprehend. Each developing lymphocyte shuffles gene segments to produce a unique receptor, and the resulting diversity runs into the hundreds of billions of possible configurations. Statistically, somewhere in the body there is almost certainly a cell already prepared to recognize a virus that has not yet evolved. When that virus finally appears, the immune system does not invent a new weapon. It locates the one it already made and mass produces it. This is why the popular image of immunity as a simple defensive wall fails so completely. The system behaves less like a wall and more like a vast, distributed intelligence network, constantly generating hypotheses about what might attack and quietly retiring the ones that prove useless. Understanding how this network actually works and where it actually lives has upended assumptions researchers held for decades. For most of the 20th century, immunology taught a tidy division of labor. The innate immune system, the older evolutionary half, handled the first hours of any crisis, skin barriers, stomach acid, and patrolling cells such as macrophages and neutrophils that recognize broad patterns shared by whole classes of microbes. The adaptive immune system, unique to vertebrates, arrived later with surgical precision. T cells and B cells are tailored to one specific pathogen and are capable of remembering that pathogen for decades. The handoff between these two branches is where much of the real work happens. Specialized cells called dendritic cells act as translators. They patrol tissues, engulf suspicious material, then travel to lymph nodes, carrying molecular evidence of what they found. There, they present this evidence to naive T cells, effectively showing them a wanted poster. The T cells that recognize the poster activate, multiply, and differentiate into combat units that circulate through the body, hunting the specific intruder. Meanwhile, B cells in the same lymph nodes refine their antibodies through a process of rapid mutation and selection, iterating toward molecules that bind the pathogen more tightly with each round. Research, published in 2025, revealed that B cells actually pause this mutation process during their fastest bursts of replication, then resume it afterward. The trick lets the body generate enormous numbers of good antibodies without accidentally breaking the successful ones. It is protein engineering happening inside a lymph node with no designer. Here is the fact that tends to stop people mid-sentence. Roughly 70 to 80% of all the immune cells in the human body do not live in the blood, the spleen, or the lymph nodes. They live in the intestines. The gastrointestinal tract is not simply a digestive organ. It is the largest immunological organ in the body, and it is where most immune education actually takes place. The reason is straightforward, once stated plainly. The gut is the body's busiest border crossing, processing trillions of microbial cells and countless foreign molecules every day. A dense layer of lymphoid tissue lines the intestinal wall, packed with T cells, B cells, and sentinel cells that must perform a delicate judgment call thousands of times per minute. They must tolerate the harmless bacteria that keep the gut functioning while attacking anything genuinely dangerous. Get the balance wrong in either direction, and the result is either infection or autoimmune disease. This training is not metaphorical. From birth, resident microbes physically teach developing immune cells what to ignore and what to destroy, shaping the population of regulatory T cells that enforce tolerance. Gut bacteria produce short-chain fatty acids by fermenting dietary fiber, and these molecules directly influence immune cell maturation throughout the body. A low-diversity gut, starved of fiber, produces a poorly calibrated immune system, one more likely to overreact to harmless triggers or underreact to real ones. For decades, the textbook definition of the innate immune system included the phrase, "no memory." That phrase is now wrong. Beginning with observations in the early 2010s and accelerating dramatically in the last few years, scientists have confirmed that innate immune cells, especially macrophages, can learn from previous encounters and respond differently the next time. The phenomenon has been named trained immunity, and it is forcing immunology textbooks into a quiet crisis. The mechanism is not the same as adaptive memory. Rather than rearranging DNA, trained innate cells undergo epigenetic reprogramming, meaning chemical tags are added to their chromatin that change which genes are easy to switch on. A macrophage that has encountered an inflammatory signal may, weeks later, respond twice as aggressively to a completely unrelated pathogen. A 2025 study that tracked macrophages through 80 different exposure conditions found that whether a cell becomes primed to react harder or tolerant and quieter depends on the dose and duration of the original encounter. Short, mild exposures tend to prime. Heavy, sustained ones tend to induce tolerance. This discovery reframes phenomena that were previously mysterious. It helps explain why some vaccines protect against diseases they were not designed to prevent, why survivors of severe infections are sometimes unusually vulnerable to secondary ones, and why the same inflammatory trigger can leave one person resilient and another permanently overreactive. The innate system, it turns out, has been keeping notes all along. What emerges from all of this is a picture of the immune system that is almost nothing like the one most people carry around in their heads. It is not a fortress. It is not a standing army. It is a living, learning, distributed network that is constantly being shaped by what enters the body, what lives in the gut, and what the cells have already seen. Its competence on any given day is largely the result of conversations it has been having with the environment for years. This reframe has real consequences for daily life. Evidence on fiber and plant diversity is now strong enough that nutrition research routinely treats dietary variety as an immune intervention, not merely a digestive one. Sleep, long dismissed as peripheral, emerges as central because immune consolidation and epigenetic regulation depend on it. Unnecessary antibiotics, especially in early childhood, can leave durable fingerprints on immune calibration by disrupting microbial education during critical windows. The deeper lesson is more philosophical. Immunity is not something a person possesses in a fixed amount, like fuel in a tank. It is something maintained through ongoing dialogue with a world full of microbes, most of which are not enemies. The cells that protect us were taught by the very organisms we tend to fear. A healthy immune system is evidence of countless small encounters, most of them benign, that the body learned from rather than lost to. Defense, in the end, is an education. Thanks for watching. If you have anything to add, drop a comment below. Don't forget to like and subscribe for more videos exploring the world around us.